Imagine flying in an airplane that's faster than the speed of sound. They're all about going super fast, and when you see them zoom by, it's mind-blowing. Fighter jets, in particular, are like the superheroes of the skies, using their incredible speed and technology to handle high-stakes missions. From World War II until now, the United States and Russia have been in a thrilling competition to create the best warplanes. Just when we thought things couldn't get any cooler, the United States has unveiled a brand new type of fighter jet called a hypersonic one. This announcement has made people everywhere super curious and excited. Today, we're going to spill all the beans about this amazing new creation. The United States Air Force has always been a leader in inventing incredible war machines. They've taken it up a notch with this hypersonic fighter jet. It's not just about being faster, it's about being the fastest. This new plane is making waves and might just be the most impressive flying machine yet. Let's dive into the details of this thrilling innovation. The SR71 Blackbird. In the thrilling world of aviation, there once existed a marvel that soared above the clouds with unmatched speed and grace: the SR-71 spy plane. Imagine the fastest airplane ever built, zipping through the skies with an elegance that seemed almost otherworldly. This incredible aircraft was not just fast, it was a true work of art, designed with a sleek body and the ability to fly at incredibly high altitudes. But what made it even more extraordinary was its ability to remain hidden from prying eyes. The SR-71 had a special quality called stealthiness, meaning it could avoid detection. Its body was crafted with rounded edges and carefully blended components, leaving no sharp angles that could give away its location. This made it a master of disguise, a ghost in the sky. Think of it as a high-tech ninja of the clouds, silently gliding through the air, leaving a mark on history. The story of the SR-71 dates back to the 1960s, a time when brilliant engineers were already dreaming of creating aircraft that could escape notice, just like a secret agent in a spy movie. Back then, the idea of building a plane that could break the Mach 3 barrier, meaning it could travel 3 times faster than the speed of sound, was nothing short of audacious. But guess what? They did it. The SR-71 Blackbird shattered this barrier, becoming a symbol of human ingenuity and pushing the boundaries of what was possible in aviation technology. Even today, more than 60 years after its first flight, the SR-71's legacy lives on. Equipped with advanced technologies like side-looking radar, signals intelligence capabilities, and long-range cameras. These features allowed it to gather crucial information from far away, helping the military make important decisions while remaining hidden from enemies. The enigma of the Aurora. In the high-stakes world of super-fast aircraft, the United States is in a race to create something even more incredible than the legendary SR-71. That's why the SR-71 had to retire, making way for its offspring, the SR-72, lovingly called the son of the Blackbird. This secret project is being handled by the experts at Skunk Works, a renowned aerospace organization. The idea of a successor to the SR-71 emerged in 2007 when some confidential information about a contract between the U.S. Air Force and Lockheed's Advanced Development Projects Division, Skunk Works, leaked. Their goal was to build an aircraft that could cruise at an astonishing Mach 6, which means it could fly at over 4,600 miles per hour. This incredible machine is designed to travel across continents at altitudes of around 100,000 feet. Initially, they were aiming for a debut in 2020, but that timeline seemed a bit ambitious. Before the SR-72, there was talk of another aircraft called the SR-71 Aurora, or simply Aurora, as a potential replacement for the SR-71. Some believed it could fly at hypersonic speeds, exceeding Mach 5. However, this story goes back to the 1980s and 1990s when it was conceived as a possible successor to the aging SR-71 Blackbird. One of the most intriguing pieces of evidence supporting the existence of Aurora dates back to 1989, when an oil exploration engineer named Chris Gibson spotted a triangular aircraft gliding over the North Sea, sparking widespread curiosity and speculation. Another puzzling piece of the puzzle involves strange disturbances in the sky called skyquakes. These strange events have been shaking the skies over Los Angeles since the early 1990s, and they seem to point toward the mysterious Groom Lake facility, famously known as Area 51, nestled within the Nevada desert. These events offer intriguing clues about this covert aircraft. The true identity of this aircraft remains concealed, much like its existence. Such secrecy is common in the world of advanced military projects, similar to the case of the F-117A stealth fighter, which remained hidden for over a decade after its first pre-production test flight. The Aurora project falls under the technical classification of a special access program, often called black programs. It's possible that the SR-72 has replaced the Aurora project, serving the same purpose as a hypersonic fighter jet. These initiatives are secret, operating away from the public eye, just like a spy in the shadows. Fast forward to November 2013, and the SR-72 made a grand reappearance in the public eye, thanks to Aviation and Space Tech Week. The Skunk Works team had some exclusive data to share, and the buzz it created was so massive that their servers couldn't keep up. This wasn't just because people were curious. It was also because of relentless, distributed denial of service, DDoS, attacks on their servers. In the revealing article, Skunk Works outlined their long-term vision, which was to create an affordable intelligence, surveillance, and reconnaissance (ISR) platform that could fly at hypersonic speeds. Picture a sleek twin-engine aircraft with a cruising speed of Mach 6. This aircraft was built to excel in a domain where others struggle. It could penetrate enemy airspace at incredible speeds and altitudes. Lockheed Martin called this the sweet spot for air-breathing hypersonic weapons. The SR-72 had a vital mission to outperform even the most advanced subsonic and supersonic aircraft, something that regular unmanned aerial vehicles, UAVs, often struggled to do. What made it even more incredible was its ability to engage targets before they could even realize it was there, or attempt to hide from this hypersonic spy in the sky. It's like being a secret agent that can move so fast and quietly that the bad guys don't stand a chance. Flying at Mach 20. Between 2003 and 2006, Lockheed Martin was part of a groundbreaking project known as the DARPA Falcon project. This project laid the foundation for the impressive SR-72 program we talked about earlier. One of the key pieces of research during this time was the Hypersonic Technology Vehicle 2, or HTV-2 for short. This experimental vehicle was a real star, capable of reaching Mach 20, which translates to a mind-boggling 13,000 miles per hour. The goal here was to test the technology needed for the United States to be able to strike any target worldwide in just 1 hour. That's superhero-level speed. Now, creating something that could fly this fast wasn't easy. Lockheed Martin had to use a super-strong carbon composite material to build the HTV-2. Why? Well, because during its missions, the vehicle would face scorching surface temperatures that could soar above a whopping 3,500 degrees Fahrenheit. Regular steel, which might seem like a tough choice, would start melting at a much lower temperature of 2,500 degrees Fahrenheit. But the HTV-2 wasn't a lone superhero on a mission. It was part of a bigger plan. It was like the opening act for something even cooler called the HTV-3X, also known as the Black Swift. This ultimate goal was to create a reusable hypersonic cruise vehicle or drone that could take off from a regular runway. It had an impressive payload capacity, meaning it could carry around 12,000 pounds of cargo. With that kind of power, it could reach targets as far as 10,350 miles away in less than 2 hours. However, there were some bumps on this super-fast journey. During tests in 2010 and 2011, the HTV-2 faced some control and autopilot issues, which led to a dramatic conclusion when it triggered a self-destruct sequence, sending it into the vast Pacific Ocean. The dream of the HTV-3X was eventually canceled, and Lockheed Martin continued its work on the HTV-2 until 2014. They were determined to learn more and improve their techniques for designing tough casings that could withstand extreme temperatures, kind of like creating a superhero suit that can handle the heat. Jumping back to 2013, the Skunk Works team had something fascinating to share during Aviation Week. At that time, they were in the middle of an ambitious 7-year collaboration with Aerojet Rocketdyne. Their joint mission was to figure out a way to build a complete hypersonic engine with a scramjet. Now, this engine had an incredible job. It had to launch an aircraft from a standstill and propel it to speeds faster than Mach 6, which is like going 6 times the speed of sound. This approach was rooted in the foundation of the previously canceled HTV-3X project. But Lockheed and Aerojet's subsequent work took things to a whole new level. They focused on tackling a major technical challenge, the high-speed gas turbine engine. It's kind of like trying to build an engine that can do it all, work at slower subsonic speeds, super-fast supersonic speeds, and the lightning-fast hypersonic speeds. They wanted to create an engine that was like a Swiss Army knife for propulsion, tailored to handle each phase of flight, whether it's taking off, cruising, or zooming at hypersonic speeds. It's like giving an aircraft the ultimate power tool to conquer the skies. The Combined Cycle Scramjet. As of June 2017, Lockheed Martin's Executive Vice President and Chief Program Officer of Advanced Development, Rob Weiss, confirmed the maturation of hypersonic technology in an interview with Aviation Week. They worked closely with DARPA and other agencies on a challenging journey to introduce new capabilities for the U.S. fighter fleet. Weiss's words weren't just about technological progress, they promised a revolution in American aviation. This brings us to a critical aspect of the SR72 project, the integration of a combined cycle engine and other technologies related to hypersonic flight. Currently, the United States is actively advancing over a dozen promising hypersonic programs, and the SR72 is often linked with Mayhem, a secretive U.S. Air Force initiative focused on creating expendable test beds for cutting-edge jet engines, including turbine-based combined cycle designs. To understand the importance of this, we need to look at how these engines work. Traditional jet engines rely on a centrifugal compressor or rotating fan blades to compress incoming air. Then they mix it with fuel and ignite it for scramjet propulsion. While these engines achieve impressive speeds, they face limitations at lower velocities when air pressure drops. This means that aircraft equipped with such engines can't perform well at slow speeds required for landing, making them single-use assets. This is where the combined cycle scramjet engine comes into play. It seamlessly integrates a traditional jet engine, allowing the aircraft to operate like a standard plane and be reused multiple times. According to aviation experts and engineers, this engine type holds enormous promise in both defense and air transport. So far, no nation has successfully harnessed scramjets for rockets or aircraft. But the United States is determined to pursue this ambitious goal. It's like opening a new chapter in aviation history, one that promises faster and more efficient flight. Hypersonic breakthrough. In March 2022, Lockheed Martin achieved success in hypersonic weapon tests, marking a significant milestone in this technology. This project is an extension of the scramjet concept used to create the HWC. However, it's important to note that they're currently using only a part of the combined cycle engine required for the SR-72's ultimate success. The challenge the Air Force faces is how to power a conventional jet engine without disrupting airflow to the scramjet while keeping the aircraft lightweight. This intricate balancing act between technology and engineering highlights the relentless pursuit of hypersonic capabilities in the United States. This path is challenging, but the potential rewards are immense, promising to reshape both defense and aviation landscapes. The SR-72 is at the forefront of this exciting endeavor on the global stage of innovation and competition. The Mayhem project and other hypersonic aircraft developments have chosen a unique path. Instead of relying solely on invisibility, they prioritize achieving incredible speeds. This strategic choice allows these aircraft to boldly traverse enemy territories, rapidly collect vital data, and reach their targets before swiftly exiting. However, the quest for hypersonic reconnaissance planes like the SR-72 and its counterparts involves more than just speed. It encompasses essential aspects, such as designing these aircraft to serve as ammunition depots, a vital element of their future missions. Moreover, they must face the daunting challenge of enduring extreme temperatures, an inevitable consequence of traveling at Mach 5 to 6. This challenge isn't limited to just the materials used, but extends to the aircraft's electronic systems. These electronics must withstand punishing speeds throughout the entire flight while maintaining stable communication connections. This reliability is paramount, enabling precise maneuvers and ensuring that these aircraft can navigate through a maze of defense systems, even under the most demanding conditions. Beyond their role in intelligence gathering and reconnaissance, the SR-72 can also serve as a formidable weapon platform. The aircraft's specifications suggest an inherent capability to engage targets using specially designed hypersonic missiles. This combination of hypersonic aircraft and projectiles holds the exciting prospect of infiltrating denied airspace and delivering precision strikes across vast continental expanses. It's like the future of aviation and defense rolled into one thrilling package. Hugh Bradley, the program manager at Lockheed Martin, has rightly recognized that speed is the next pivotal advancement in aviation. It's poised to counter emerging threats in the decades to come, much like how stealth technology has reshaped the modern battlefield. Hypersonic capabilities promise to be a game-changer in the theater of conflict. However, the path to realizing hypersonic weapons isn't without its hurdles, and one major obstacle is the complexity of designing a universal engine suitable for aircraft like the SR-72. Additionally, designing a missile that can endure the blistering air friction at hypersonic speeds and yet remain maneuverable poses a formidable difficulty. Think about the complexities of steering such a missile mid-flight. Its turning radius would span hundreds of miles, and the fuel consumption would be colossal. Therefore, not only must the SR-72 address the intricacies of hypersonic propulsion, but its weaponry demands pioneering technologies as well. Costing the future. Another significant challenge in developing hypersonic technology is the issue of cost. Preliminary estimates from the Pentagon suggest that the current price tag for hypersonic missiles falls in the range of $90 to $110 million. To put this in perspective, the latest Lockheed Martin F-35A Lightning II stealth fighter costs approximately $80 million. This is a stark contrast to the bygone era when the old Blackbird, the SR-72's predecessor, was manufactured for a mere $23 million per aircraft back in the 1960s. It's essential to recognize that the capabilities of the SR-72 and its predecessor are vastly different. When discussing a potential prototype successor to the Blackbird, former Lockheed CEO Marillyn Huston pointed out that it would be akin to the F-22 Raptor and carry a price tag of less than $1 billion for each aircraft. This acknowledgement underscores the monumental strides and advancements made in the field of aviation and weaponry, highlighting the complexity, diversity, and evolving nature of the challenges that accompany it. On the other hand, we must approach the data with a degree of flexibility, as they are not set in stone. That said, an interesting point of comparison emerges when we consider the cost of cutting-edge military technology. In December 2022, the futuristic B-21 Raider strategic bomber garnered attention with a hefty price tag estimated at a substantial $700 million per unit. This raises an important question about how the SR-72 would measure up in this context, adding another layer to the intrigue. The SR-72 rekindled public interest when it made a captivating cameo in the long-awaited sequel to the iconic movie Top Gun, which hit theaters in the spring of 2022. The film showcased the enigmatic Dark Star Hypersonic aircraft, a creation from the very same Skunk Works division that's been at the heart of SR-72 speculations. While information about this aircraft initially surfaced through official Lockheed Martin channels, what truly piqued curiosity was the company's suggestion that the characteristics of the Dark Star aircraft might transcend the realm of cinematic fiction and find a place in our reality. This innovative design would bring with it a host of advantages that effectively neutralize some of the weaknesses of its illustrious predecessor, the SR-71. Leveraging modern technology, engineers will re-evaluate the Blackbird's mission design, shedding the limitations imposed by 1970s-era technology. Notable improvements include eliminating the need for laborious launch countdowns akin to those of the Space Shuttle and dramatically reducing turnaround times. The SR-71 once required over a week to prepare for a subsequent flight, a stark contrast to the agility envisioned for the SR-72. Furthermore, the SR-72 offers a paradigm shift in terms of piloting. While it can accommodate human pilots, it's equally proficient in remote operations, obviating the need for onboard crews. The aircraft boasts the capability for enhanced acceleration and tighter turns, enduring greater G-forces, which rectifies one of the SR-71's historical vulnerabilities. The SR-72 embodies a bold leap into the future of aviation, weaving together groundbreaking research, technological innovation, and a vision of supersonic possibilities. According to Lockheed Martin's plan, it is slated to grace the skies by 2025. There's even a thought-provoking notion that the SR-72, or perhaps a flying prototype, is already operational, concealed in the American desert.